In this video, we are learning the topic thermal physics, and there are few important topics which I wanted to explore so that you can solve the questions related to it. So the first topic is understanding the phase change of matter. For example, how the solid converts to liquid and liquid converts to gas. Then what is specific heat capacity of the matter? For example, you can take the specific heat capacity of liquid or specific heat capacity of solids. And the next topic is what is the specific latent heat? Sometimes it's called as latent heat. Let's start with the phase change of matter. Imagine you have few ice cubes kept in a container. 4 to 5 ice cubes which I'm drawing here. So these are the ice cubes. Let's say they are kept in a container and the temperature of all the ice cubes is around minus 10 degree Celsius. And now you started supplying heat to this container. So as the time goes on, the temperature of these ice cubes will start rising and slowly it will reach towards 0 degrees Celsius. So let's add a graph of change in temperature of these ice cubes with respect to time. So on this graph, I'm taking time on x-axis, t in seconds, and change in temperature, or you can simply say temperature on y-axis, which is in degrees Celsius. Since our ice cubes are at minus 10 degrees Celsius, I'm taking the initial temperature somewhere here as minus 10 degrees Celsius. So this becomes our reference point. Now, as you know, the time cannot be stopped. It will keep going at its own speed. So as the time is passing and you are continuously supplying the heat, the temperature of the ice cubes increases and it reaches to 0 degree Celsius. So here is the 0 degree Celsius. Now you will find one interesting thing. When the temperature reaches to 0 degrees Celsius, there will be no further change in temperature until and unless this ice completely melts and converts into the liquid. And again, as I said, the time will continue to flow at its own speed. So time is increasing, but there is no change in temperature. So here is this constant temperature graph for some time. Let's say this is the time duration. When all the ice melts into the liquid, again, because you are continuously supplying the heat, temperature of the liquid starts rising, and the temperature will start rising something like this, and it will keep on increasing until the liquid reaches to a boiling point. And let's say if it is water, of course it's water because it's ice. So here we can add the boiling point as boiling BP as 100 degrees Celsius. So let's say the top of this graph is at 100 degrees Celsius, and again when the water reaches to 100 degrees Celsius, change in temperature will stop. There will be no further change in temperature, and at this stage the liquid starts converting into gas at very rapid speed. So you can see on the graph there are two phase changes taking place. One is from solid to liquid, which is represented by green line, and the another one is liquid to gas. Now the energy supplied during the phase change for per unit mass of substance is called as the specific latent heat of, and I will add one more word here, specific latent heat of melting, because the ice is melting. And similarly, the energy supplied per unit mass of substance to vaporize, we will add here specific latent heat of vaporization. So I have written in short S for specific, L for latent heat, LH for latent heat, and O for of V for vaporization, which I will explain you in detail in the next slide. Now, if you will focus on this region of the graph and this region of the graph, so here you can see as the heat is getting added to the matter, the temperature of the matter is increasing continuously. So here you can see the change in temperature. So now you may be thinking why there is no change in temperature during the phase change, why the temperature remains constant, right? If that is the question, then here is the answer. If you want to read it, you can read it, but I'm going to explain it to you. So what happens during the phase change, all the heat energy supplied to the substance or supplied to the matter is utilized to break the molecular bond between the solids or between the liquids. Let's say if there is ice which is melting to the liquid, then the bonds which are broken are between the molecules of two solids, and when the bonds between the molecules of two solids are broken, they convert into liquid. Similarly, if there is a liquid and now that liquid is vaporizing at boiling point, so the bond between the liquid molecules is getting weaker and weaker, and all the energy given to the liquid is utilized to weaken the bond between the liquids so that the vaporization can take place. So this is the reason there is no change in temperature, because all the energy is getting utilized to break the bond. Now let's talk about the specific heat capacity. What is specific heat capacity? Imagine I have 1 kg of metal here, right? So 1 kg of any metal. Now if I start supplying heat to this metal, then there will be change in temperature. Now imagine if that change in temperature is by 1 degree Celsius or by 1 Kelvin. It doesn't matter which scale you choose, but that should be by 1 degree Celsius or 1 Kelvin. So the heat capacity can be defined as the amount of heat required to raise 1 kg of substance by 1 degree Celsius. If you are doing a practical, let's say in your physics lab, then you will find that the heat supplied, let's say heat is represented by Q. So heat is represented by Q. Heat supplied to the substance depends on the mass of substance. Heat supplied depends on the change in temperature, how much is the change in temperature you are doing or you are achieving, and heat supply depends on the type of material which decides its specific heat capacity. So it depends on S as well. So we can write here Q is equal to ms delta T, right? Now here m is the mass, S is the specific heat capacity, delta T is the change in temperature. So if you want to calculate specific heat capacity, you can write S is equal to Q by m into delta T. This is the formula of specific heat capacity. Now if you want to know what is the unit of specific heat capacity, so you can see here and apply the concept of the fundamental units. The unit of Q, which is heat, is joule. Unit of mass here is kg, and the unit of change in temperature is Kelvin. Or similarly you can write joule divided by kg and degree Celsius. Now let's understand the concept of specific latent heat. So As you know, there is no change in temperature during phase change. So delta T is equal to 0. So here no use of delta T. Now if there is change in phase taking place for a solid to liquid or liquid to gas, then you know the temperature remains constant and the heat supplied, heat here I will write as Q, depends on the mass of substance. So I can write here Q is equal to L. L is a constant here into M. Now this L depends on the type of material, and this L is called as the specific latent heat, and the formula is written as L is equal to Q by M. Why it's called as specific latent heat? Because the heat is required for per unit mass of substance. So let's write here, it's called as specific latent heat, right? So this L is equal to Q by M represents energy per unit of mass, and this is what the energy required to change the phase of 1 kg of substance. In next video we are going to solve some questions related to specific heat capacity and specific latent heat capacity. See you in the next video.